Let's talk about how to actually use a vector database in real projects. We'll walk through the main steps, real examples, and how AI plays a role in the workflow. So you've heard about vector databases, and now you're wondering, how do I actually use one? What does it look like in code, and what can I do with it? Let's break it down. Step one is data ingestion. And this is where you bring in the content you want to search through. It could be documents, PDFs, product descriptions, user queries, support tickets, etc. The important thing is that this data is meaningful in a semantic sense. Step two is embedding generation. You take your raw data and pass it through a model that converts it into vectors. These are high-dimensional numerical arrays that capture the meaning of the input. You can use models from OpenAI, Hugging Face, Cohere, or open source ones like sentence transformers. Step three is storing the vectors. Once you have your embeddings, you store them in a vector database like Pinecone, Face, Weaviate, or Qdrant. These databases are optimized for fast similarity search across millions of vectors. Now you're ready to query. When a user sends a new question or prompt, you embed that query the same way and then search the database to find the closest matches, the most semantically similar vectors. The result? You get back the original data entries associated with those similar vectors. This enables AI-powered search experiences where users don't need to know the exact wording. They just describe what they want. Let's walk through a few examples. Example one, FAQ search. You have a collection of support FAQs. You embed each question and answer into vectors and store them. Now, when a user asks, how do I change my password? The system returns the most semantically similar answer, even if the original FAQ says to update your login credentials. Example two, product recommendations. You embed product descriptions, reviews, and tags. When a user interacts with one item, you embed their behavior and retrieve similar products in meaning, not just tags. Example three, context retrieval for LLMs. RAG. You chunk a long document, generate embeddings for each chunk, and store them. When the user asks a question, the system retrieves relevant context from the chunks before feeding it to an LLM for a rich, informed answer. This is what makes vector databases so powerful. They turn data into intelligence, and they're not just for research labs anymore. Companies are using them in chatbots, customer support systems, content platforms, legal tech, medical search, and more. In short, using a vector database means embed your content, store the vectors query with AI, get semantically relevant answers. Thanks for watching Big Data Now. If you found this helpful, check out our next video, where we'll build a small example pipeline using a vector database step by step.